Alright, so this lesson is going to be about equations, making equations if you're given a point and some slope. And sometimes we might have to figure out that slope as well. But the idea is we're just looking for the equation of a line in this particular lesson. Okay, so just a quick little warm-up, just as a reminder about some key things about lines. So let's determine the slope and the y-intercept of the following. So let's say if we have an equation in this form. So if we have an equation written like this is what we call y equals mx plus b form, where you have your y on the one side and then x and a number on the other side. And if it's in that form, the m value, or the number in front of x, is your slope, and the number at the end, sometimes called the b value, is the y-intercept. So for this, m is going to be equal to 3, and b is going to be equal to 4. So that's your slope, and that's your y-intercept. All right, let's take a look at the graph on the right. So if we're looking at a graph, we need to also remember that slope can be thought of as rise over run, or rise divided by run. So we just need to look at 2 points on the graph. There's already 2 kind of highlighted here that we can travel between, in a sense. And then we have to see how far up do we go and how far across do we go to get from one point to the other. So from there to there, we went up 2 grid points and across 1. So this is our rise and this is our run. And so because of that, our m value is going to be 2 over 1. Or you can simplify it to 2. All right, what about the y-intercept? Well, the y-intercept is just simply where does it cross the y-axis? And the y-axis is the vertical line, so it's this line going downwards, and it crosses right here. So y equal to -1 is the y-intercept. All right, so that's just a quick reminder of some key properties of lines. All right, so next, let's actually create an equation of a line, and we're going to look at a few examples with these following properties. So let's say a line has a slope of 3 and a y-intercept of -2. Well, again, let's just remind ourselves of, in a sense, the line equation, y equals mx plus b. Well, if we know it has a slope of 3, well, that just means m is equal to 3. And if it has a y-intercept of -2, that just means b is equal to -2. So we can just place those numbers into the equation. So for m, replace it with 3, leave the x there. And for b, replace it with -2. And since we have a negative there, we can actually simplify this just one more step. Instead of saying plus -2, you can just right away go to -2. And there we have our equation of the line. All right, what about the following? What if we were just given 2 points? How do we actually get the equation of the line? Well, we still want to go through and use y equals mx plus b. We just need to figure out what's m and what's b. So step 1, let's figure out the slope. So we're saying we're going through these 2 points, 3, 2, 0, 1. Well, this is where we have to think back to another alternate version of the slope that we looked at, which basically said we're looking at the difference in the y values over the difference in the x values. Or another way to write that out, the difference is just you're taking your 2 y coordinates, subtracting them, and you're taking your 2 x coordinates and subtracting them. So that's what that's talking, or that's what that equation means. So if we take our 2 y coordinates, you have 2 and 1. So you can do 2 minus 1. And if we take a look at our x coordinates, you have 3 and 0. So you'll do 3 minus 0. And if you do that, on the top you'll have 2 minus 1, which is 1. On the bottom, 3 minus 0 is just 3. So 1 over 3 is the slope. All right, what about our b value, as in the y-intercept? Well, it's kind of hard to figure out right now because we don't have a graph. So how could we possibly know this? Well, what we do know is the point 0, 1 has x coordinate 0. And since the x coordinate of that point is 0, that actually means it's the y-intercept. So that point itself is the y-intercept. So if we want the b value that we use in the equation, we just take a look at the y-coordinate. What's that value? Well, it's just 1. So it was actually there, but it was just there in disguise. And combining that information, y equals mx plus b, take our slope value, 1 over 3, and we're going to write that in here. So 1 over 3x, and then take our y-intercept value and write that at the end. So plus 1. And there we have it. We have the equation of the line given just 2 points on the graph without even having to use an actual graph. All right. What if we were given a point and some slope? How do we get that equation? So there's going to be a couple of ways to do this. So we're going to first of all do this with a graph, and then we're also going to do it algebraically. Okay, so first, using a graph. So make sure to get this into your note. But how you could do this is you could plot the point that we're given, so the point A, then find other points on that line by using the slope, and we'll go over that again. And then eventually you can determine the y-intercept. And when you have the y-intercept, then you'll have all the information. Okay, so let's start by plotting the point. So 0.43, you go across 4, and you go up 3. There's the point A. Okay. Next, we have our slope of 2. So remember, m equals 2. That means it's like 2 over 1. And if you're thinking rise over run, for every 1 you go across, you're going up 2. And we can use that to find a new point. So up 2 and across 1 gets you a new point. But you could also go backwards. So you can see kind of the general pattern that might occur. So back 2, and since we're going backwards, we'd just go down 2. Or sorry, back 1, down 2. And you can continue that pattern. And you can keep getting points after point, and continuing backwards, another point, and another point. And then we get to the y-axis. And so we can join up these points in a nice straight line. A ruler does wonders here. And there you have your line. So I'll just add here up 2, across 1. And you're doing that for the entire line. Okay, so how's that going to help us get the actual equation? Well, for the equation, we already have the slope, m equals 2. So that's our starting point. But we need the b value. But now that we've graphed it out, we can just go straight to our graph, straight to the y-axis, and we'll, on there, we can see where it crosses, and it's at -5, so b is equal to -5. And so combining those two pieces of information, you get y is equal to 2x minus 5. So again, the m value becomes the front number, and the b value becomes the back part. All right, but is there another way to do this? Because maybe you don't have a grid set up right there for you. how else could you solve this? And this is going to be a very important method going through it algebraically. So what we can do is we can actually create the equation, just a general form of the equation, with parts of it filled in. And then we can actually solve for our y-intercept just using algebra. So what do I mean? Well, we know m is equal to 2. So what I could do is I could already start writing this equation as y equals to 2x plus b. So we know it has to look like that based on just the slope being 2. We don't know what b is yet, but that's what we're going to find out. The second part is we can substitute our point in. So we have a point, the point 43. And we can substitute that into the equation. So what does that actually mean? Well, let's take a look at the coordinates of this point. For the point, the x coordinate is 4. And also the y coordinate is 3. So we could say x is equal to 4, y is equal to 3. Why does that matter? Well, when we substitute that into the equation, what we can do is, where we see y, so at the front, y is normally there, but now instead of y, we can replace that with a 3. Continue writing out the equation, so 2x, where x is, now we replace that with a 4. So 2 times x becomes 2 times 4, plus b. We still don't know what b is, but it's just some unknown number. All right, but now we can solve for b. Okay, so how do we solve for b? Well, let's just multiply it 2 times 4 first, so 3 equals 8 plus b. And then we want to get b all by itself, so the 8 is on the same side as b. So move the 8 over by subtracting it, so minus 8. 3 minus 8 gives you negative 5. So b is equal to negative 5. All right, but now we have the b value, that's the y-intercept, and that matches up with what we found doing the graph. And so now we can write the equation. Y is equal to 2 for the slope, x minus 5. There we go. All right, so let's try just another one algebraically. It's a good strategy to get you to. Try it out yourself, and I'll go through it here as well too. So if we have a line through the point 2, 4 now with a slope 3. So again, first, we have our slope 3, so we can write down the general equation, so y equals 3x plus b. And then we want to substitute in 2, 4 into the equation. And so that means x equals 2 and y equals 4, just based off the coordinates of the point. So now we have to place those numbers into the equation. Just always be careful, because in the coordinates of your point, x comes first and then y, but in the equation of the line, y is first and then x is afterwards. All right, so we have 4 equals 3 times 2 plus b, and now we solve for b. Okay, and solving for b, what do you get? Well, you're going to get 4 is equal to 3 times 2, which is 6, plus b. And, okay, I'm just going to rewrite that. 4 equals 6 plus b. That 6 beside the b, we want to move that over to the other side. So we subtract it, and you're going to get 4 minus 6, which is just negative 2 equal to b. All right, so there we have our value for b, we have our value for m. Combining the two together, you're going to get y is equal to 3x and negative 2. So we get a minus 2 there at the end. And that is our equation of the line. All right, so given a point, given a slope, we now have a method to always give us the equation of the line. Sometimes, though, you may not be directly given that slope value. So you may just be told, oh, we have a line and we know it's parallel to this other line. Or, oh, we have this line, but it's perpendicular. So just a couple of reminders. If a line is parallel, it has the same slope, or the two lines have the same slope. Whereas if you have a perpendicular line, the slope of that line to the thing that is perpendicular to, we say is the negative reciprocal. Negative reciprocal meaning, let's say if you had a slope of 1 over 2, well, the negative reciprocal is just flipping the fraction, 2 over 1, and turning it into negative. So negative 2 over 1. All right, so what would the slopes be of the following lines? So if we had a line parallel to y equals 3x minus 4, well, we just need to identify what the slope is in that given line. So m equals 3. And since it's parallel, it'll be the same. So m equals 3 itself. All right. What about the second one? So b, if we have a line perpendicular to y equals 5x minus 7. So again, based off the equation, the number in front of x, we can use that to identify our m value of 5. Since it's perpendicular, that's going to mean m is going to be the negative reciprocal. So take that slope, flip it, so we can do 1 over 5 in this case, and turn it into negative. So negative 1 over 5. I'll just add that as a note. So negative reciprocal. And there we have it. We have the slope. And so yeah, when a question mentions something like parallel or perpendicular, you can always use that to find your slope value and then tackle the question like we did with the other parts. All right, so that's everything in terms of this lesson. So you can now hopefully have an idea of how to create more types of equations of lines in these different types of situations.